this video, we are going to discuss about equations of motion. The chapter is motion. I have already discussed with you some of the terms of this chapter which are used in this chapter. Okay, now today we are going to discuss the equation. What are the equations of motions? Actually, the equations which are used to represent or describe the motion of the moving bodies, the bodies which moves, okay, their motion is described. What is the velocity? If it is in rest, what is the initial velocity? If it moves, what is the final velocity after stop? When it stops, what is the final velocity? You should keep in your mind that initial velocity need not be zero always, because if the body is at rest or if a car does not start, it is at rest, then you can say its initial velocity is zero. Otherwise, if a car is moving with a speed and after that it changes the speed to some other speed. For example, if a car is, if we are driving a car at a speed of 60 km per hour, at the speed of 60 km per hour, its initial velocity is 60 km per hour. And after that, if we accelerate, if we press the accelerator and the car accelerates with some more velocity, for example, it becomes 80 km per hour. Okay, then that 80 km per hour will be the final velocity. But what if you say that the final velocity is always greater? Initial velocity was 60, the final velocity was 80. That means the final velocity always be greater. No, not always. Because if we have the speed of the car as we drive the car at the speed of 60 km per hour, and after that we stop the car, the final velocity becomes zero.
Yes.
At the time the car stops, the final velocity will be zero. At the time when the car does not start even, then the velocity of the car, initial velocity of the car is zero. So we can't say that the initial velocity is always less than the final velocity, or the final velocity is always greater than initial velocity, or even we can't say that the initial velocity is always zero, and we can't say that final velocity is always zero. It can be any number, anything. Okay?
So it depends on case.
In some other cases, yes, there may be some case in which the final velocity is zero. And what is that case? In that case, we have applied the brake and the car or vehicle stopped. Okay. Now the equations are these equations that describe the motion of the moving bodies. The linear motion of the bodies are: first one is v is equal to u plus at. Second one is s is equal to ut plus half at square. V square minus u square is equal to 2s. What are these symbols used? U is the initial velocity, V is the final velocity, T is the time taken, A is the acceleration of the body, S is the displacement of the body.
So this formula is used in acceleration also.
Yes, for acceleration, for time. If we want to find the value of the acceleration, then again it will be used.
Okay,
if we want to find the initial velocity or final velocity or time taken or displacement, then these are used. These are actually used for the uniformly accelerated motions.
Sir,
okay.
Retardation, sir.
Yes.
Retardation.
For retardation?
Yes.
Retardation, yes. For retardation even, you can use these properties. How? In place of acceleration, when it is positive, you have to use the sign minus.
Yes, sir.
So as to say that it is retardation of the acceleration. Okay?
Yes, sir.
Now,
Yes,
what are the proofs? I can prove these equations by the various methods. So one of the method is graphical method. This is graphical representation of the equation of motion. Okay?
Yes, sir.
Firstly, I have told you that what is the acceleration? Acceleration is actually the ratio of change in speed to the time taken. So, ratio of change in speed to the time taken is called the acceleration. So, we can write acceleration of a body is given by A is equal to change in velocity upon time. Now, you can say what is the change in velocity? We can say if we subtract the initial velocity from final velocity, it becomes change in velocity.
Yes, sir.
What is the actual change in velocity? Initial velocity to final velocity when we go. Then what is the difference between the two? That is the change in velocity. So v minus u upon t. It is in case of acceleration. So please listen. If it is in case of acceleration, it is v minus u upon t. If we write u minus v upon t, then what will happen? It will be in minus. So acceleration is minus means there is retardation.
Yes, sir.
You have asked me the question.
It will become in negative.
Yes, negative. Why? Final velocity is less than the initial velocity. Final velocity, that is v, is less than the initial velocity. Then it becomes u minus v. Means the sign will be negative, so it will be retardation. Okay. Now cross multiplying this, we get a t is equal to v minus u, v minus u. This minus u comes here and change its sign to plus u. So it becomes u plus at is equal to v, which was v is equal to u plus at, the first equation of motion. Now, second equation of motion can be found by using the graph, by using the concept of the trapezium.
Trapezium.
Okay?
Yes.
So I have drawn here the graph. What this graph says, actually this graph is in between the velocity and time. So it is called a velocity time graph. Okay? Velocity taken along y-axis, positive y-axis, and along the positive x-axis time is taken. Okay? Along positive x-axis time is taken. So we can, as I already told you, that initial velocity need not be zero always. So I have taken the initial velocity here. Here the velocity increases. I have taken initial velocity here and final velocity here. So initial velocity increases along with the time increment.
Yes, sir.
Time also increases with it. So I have to draw the graph like this. If time only changes and velocity doesn't change, then the graph will be like this.
Yes, sir.
That is, if it goes upward, that means velocity is changing.
Yes, yes.
If it goes like this and doesn't go upward, then it means time changes, but the velocity doesn't
not
change.
changing.
Velocity still remains the same. Initial velocity and this is final velocity. Okay, I have taken this in increasing order. I have taken the acceleration. Okay, so it is initial velocity and here it is final velocity. Here it is final velocity u and v. Okay, so initial velocity is here. I have taken the point A. From there we started the body. Actually, u was the initial velocity of the body, of the moving body. Okay, at the point where the value of u has been taken, I have taken the value of u as the point A. I consider that point A, and after that, this is the point B when the value of that velocity becomes the final velocity, that is v. Okay, u to v changes, and this is the change in the velocity actually. Okay, so this thing is equal to this one. Here it is the final velocity, na? Value of final velocity is from this to this, so this is also equal to this. Okay, now on drawing this is actually the moving motion of the body. Body moves forward as well as the upward. Forward means it has the time is increasing. Upward means the velocity is increasing. Okay, so that velocity becomes final velocity. Initial velocity to final velocity. So then this diagram is the trapezium. So we know that the area of trapezium. Why area of trapezium is needed? Because we have to find the displacement.
Yes, sir.
And the actual displacement done here is the area of trapezium only. And what is the area of trapezium? Area of trapezium is 1 by 2, that is half sum of parallel sides into height. So sum of the parallel sides are here OA plus OB. This is and this is the parallel side. Okay, OB, BC and OA. BC and OA are the parallel side. So I have taken here. Displacement is always equal to area of the trapezium ABCU. Now S is equal to, S is the displacement actually. So displacement is equal to 1 by 2 OA plus OB into OC. How it becomes? From this formula,
Yes.
from the area of trapezium. OA plus OB into OC, S is equal to half 1 by 2, it's a 1 by 2 again. So OA, value of OA is u. So there
Velocity.
OA is u, that is initial velocity,
Yes, sir.
plus BC is the final velocity. Okay, this is BC and it is taken as v. And OC, it is the time t.
Yes, sir.
I have written here t. 1 by half u plus v. And what is the value of v from the first equation of motion? It is u plus 80. It is u plus 80. So I have written here v is equal to u plus 80. U and u becomes 2u plus 80 into t into d. U plus how it is u? 2 and 2 will be cancelled out when distributive law is taken here. Okay, when distributive law is applied. Or 1 by 2 to cancel out and it is u plus half will be taken here and half 80 into t means at square. Half 80 square. u plus half 80 into t हो गया 80 स्क्वायर. अब आपको यहाँ पे पता चला होगा कि s जो होती है ना, s है डिस्प्लेसमेंट. वो डिस्प्लेसमेंट हो गई ut plus half 80 स्क्वायर. यही आपकी सेकंड इक्वेशन ऑफ मोशन है. So you can write s is equal to ut plus half 80 square from by using the concept of trapezium, area of trapezium actually. So what is the third equation of motion? It is v square minus u square is equal to 2as. We have written here using first equation. What is the first equation? This is the first equation.
Yes, sir.
S is equal to half u plus v into t. Okay, s is equal to 1 by 2 u plus v into t. Now what will I do? I will use the first equation again in this third equation to prove the third equation. It is v is equal to u plus 80 and from here we can find the value of t. What is the t? T is g minus 4 upon a. I will write this value here. T is equal to V minus U upon
A.
A. This A can be taken here.
Yes, sir.
Okay, 1 by 2A. 1 by 2A as V plus U, V plus U, V minus U. Okay,
plus B
here of an identity can be used, which is A square minus B square equal to A minus B, A plus B, or A plus B into A minus B. Okay, V square minus U square, 2A will be multiplied by S and it becomes 2AS. V square minus U square is equal to 2AS, or it becomes 2AS. So V square minus U square, or we can write it as V square minus U square equal to 2AS. This was all about today's lecture. It was the equations of motion. I have also proved them. However, these three equations of motion I have proved. So it's all about today's lecture.
Thank you.